concept, which is algebraic language. The first that you should understand it is, what is a convention? Mathematical convention is a fact or a name or a notation or a usage which is generally agreed upon by mathematicians. In algebraic expression, there are those things that the mathematicians have agreed upon. And we call those things conventions. And a convention itself, it is just the way of things is done. In algebra expression, we must recognize, identify convention for writing algebraic expression. Example of convention are as follows. 4 multiplied by x plus 1 plus y divided by 4. The red ones those are the conversion that we need to convert as it has been agreed by mathematicians. Thereby we have 4x plus 1 plus y divided by 4. Example number 2, x squared plus half plus into 4y plus 4 all divided by 2. That is the convention that I have identified in this example. And in order to write the correct way is x squared plus half plus y plus 4y plus 4 all divided by 2. From the example, the red one has been converted, the conversion has been done as 4y plus 4 divided by 2. Example number 3, x squared divided by x plus y minus 1. The red one, you need to do a convention on it, which is going to be x squared divided by x plus 1 minus 4. Number 4, y minus 2 multiplied by x plus 2. The red ones show the conversion that's supposed to be recognized and identified. Then we have y minus 2x plus 2. The last one, into y minus 2 multiplied by x plus z. And the convention when writing it is into y minus 2 close bracket x plus z. I indicated earlier to say the red color shows convention that has been recognized and identified. The green color indicates writing out of these conventions. Now, it's your time to recognize, identify, and write conventions. The red ones are those that we recognize and identify in these examples. We have to write them out. And when you write them out, it is 200 minus 5x. Number 2, into 200 minus 5 close bracket multiplied by x. This one is like as if you are doing distributive, but it is not. It is going to be into 200 minus 5x. Number 3, 5 multiplied by x plus 40. When you write it out, it is 5x plus 40. The fourth one, into x plus 40 multiplied by 5. This is, you can start by writing 5 into x plus 40 close bracket, or into x plus 40 multiplied by 5 That 5 should have been at the first when you start writing it. The last one, 5 multiplied by x plus 5 multiplied by 40. Here it's like you're going to simplify it. It will be 5x plus 200. If now we want to solve for x, if x is given as 10, meaning we have to substitute where there is x by 10. The first one, it will be 200 minus 5 into 10. And it will be 200 minus, when you multiply 5 by 10 is 50. And the difference is going to be 150. You can do the rest. Like and unlike terms. What are like terms? And what are unlike terms? What is a mathematical terms for in algebra? In algebra, a term is either a single number, a variable, or a number and a variable multiplied together. Then what are like terms? Like terms are terms that have the same variable part. In other words, the share of some variables and their exponents, but they have different coefficients. Here are an examples. Like terms. 7x, x, and also minus 2x. They have the same variable, but they have the different coefficients. What are unlike terms? Algebra terms which does not have the same literal coefficients and cannot be raised to the same power are called unlike terms. Unlike terms, examples, 4x cubed, 4x squared, 9y, 3y squared, minus xy, and 6x squared y squared. They are unlike terms because they have different variables, which are x, y, and xy, and not raised to the same power. Now we can complete the following expression by writing like terms, unlike terms, and exponents in x and or y and or xy. The highlighted ones are all like terms, which is going to be 3x squared minus 7 minus x squared and 2. Remember, like terms can be added and can also be subtracted. Don't be confused by including minus 7 and plus 2. We will explain then in the next lesson. Unlike term, in the first expression, it is 4x cubed. The last one, which is exponent in y, in x, and in xy. Here we have only the exponents. In 4x cubed, we have exponent as 3. In 3x squared, the exponent is 2. In minus x squared, the exponent is 2. Number 2, minus 32x squared minus 7 plus 43x squared minus 5x minus 12x. Like terms are being shaded red, and unlike terms are in those that are minus 7y minus 5x minus 12x. Exponents in x, it is 2 and 1. Exponent in y, it is 1 and it is 1. And exponent in xy, it is 1. Number 3, 4y plus 50xy plus 15x squared plus 11x squared. The red ones are like terms. The ones that are not colored, they are white in color, they are unlike terms. Now, exponent in x, it is 2 because we have 15x squared and another one 11x squared. The exponent in y, xy, it is 1. Remember, like terms can be added and unlike terms cannot be added. The fourth one, 25xy minus x, 18x, and minus 3z. Here, the 3 terms are unlike terms. The exponent of xy is 1, and the exponent of x is 1, and the exponent of z, though it is not written there, it is 1. Number 4, 7x minus 8y plus 10x minus 26y. Now, here, all of them are like terms. 7x is a like term, and 10x is also a like term to x because they've got the same variable. 8y and the 26y, they are also like terms. In this one, we don't have unlike terms. And the exponent of x and y, it's 1. The last one, 20x squared plus 6 plus 4y plus 3x plus 15x squared. Then 2x squared and 15x squared are like terms. And 6y and 3x are also like terms. They must be written on the like terms column. And only for y, it is the unlike term. And the exponent in x and y and or xy. Here we have only the x, the exponent is 2 and 1. And the exponent of y is 1. I think here we end up our lesson today. If you can complete that, and then you're going to be nice in the next lesson that will come tomorrow when we are going to do monomial, binomial, and trinomial. Thank you for today. Enjoy the day. And I think we found this lesson very short and nice for you. Thank you.